This is part 1 of page 2 for the review from Monday, October 15th. Let's get started. Problem number 3. Sketch an angle that measures negative 240 degrees. I'm going to stop there because it tells me what I want to do. Since it's negative 240 degrees, I know this is clockwise. And regularly, 240 degrees would be in the third quadrant, about right here, but since it's negative, I'm going to go the opposite direction. So this would be 90 degrees, negative 180 degrees, and negative 240 ends up right about here. And the last thing we need to show for this part of the problem is our direction and magnitude. So we went straight to the negative 240 degree terminal side in clockwise direction. Then we need to state the positive and negative angle that is coterminal with it. Now you don't necessarily have to draw this out, but I'm going to show you. If negative 240 is here, a coterminal angle is an angle that ends in the exact same spot. How will it end in the same spot? Well, it could go around more than once or in the opposite direction. So instead of just going around clockwise to the terminal angle directly to it, we could go around a total rotation and then go straight to it. So that is a complete rotation in the clockwise direction, negative 360 degrees, and then we went from our full rotation directly to the negative 240. And if we combine these, we get negative 600 degrees. Or in other words, a lot of you were just subtracting 360, saying you're going another rotation or a full rotation in the same direction. And that will give you the same answer, subtracting 360. Now instead of subtracting 360, we could add 360. Instead of going clockwise to my terminal side, I could go counterclockwise to my terminal side. If I add 360, I go directly to my terminal side in the clockwise direction, and I get a theta of positive 120 degrees. So these two would be your answers. One positive 120 degrees and one negative 600 degrees. Solve problem 4. Find the exact values of the 6 trig functions for the point 6, negative 3. So when you see a point, you should automatically assume it gives you x and y. And this is on the terminal side of angle theta in standard position. You do not need to rationalize the denominators, meaning you do not need to get that square root out of the denominator. Okay, so we have x and y. We're missing r. In order to find r, we know that x squared plus y squared equals r squared, the Pythagorean theorem. If I plug right into my formula using parentheses, 6 squared plus my y is negative 3 equals r squared. And let's move up here. 6 squared is 36. Negative 3 quantity squared is 9 equals my r squared. So 45 is r squared. Now, some of you have already written it as the square root of, which is what we're ultimately taking. So we're going to take the square root of r squared, and we get r equals the square root of 45. If you want to simplify this square root, we can say that 45 is the same as 9 times 5. So it's the square root of the product of 9 and 5. Properties of square roots tell me that I can split that up as the square root of 9 times the square root of 5. And I know the square root of 9 is just 3. I don't know the square root of 5, so I'm going to leave it as is. So if I write down here, x equals 6, y equals negative 3, and r equals 3 radical 5. And r, as I said in the previous video, r will always be positive. Okay, let's start plugging in. Sine is y over r, my vertical distance over my radius. Y is negative 3, so that becomes negative 3 over r, 3 square roots of 5. Now I'm going to simplify this before I rationalize the denominator. 3 divided by 3 cancels out to negative 1 over the square root of 5. If you want to rationalize the denominator, I won't penalize you for not doing so, but it does help you sometimes simplify things. So to rationalize this denominator, I multiply top and bottom by the square root of 5, and I get negative square root of 5, negative 1 times the square root of 5, divided by, now these square roots are going to cancel out because I get the square root of, the quantity square root of 5 squared, and that just cancels out the square root, and I just get over 5. So sine is negative square root of 5 over 5, or I would have accepted negative 1 over the square root of 5. Tangent is y over x. I know my y is negative 3, my x is 6, and I will ask you to simplify your fractions, so that becomes negative 1/2. Cotangent, it starts with a c, so its its reciprocal does not have a c, and it's a tangent, so its reciprocal is tangent. So that means that cotangent is x over y. My x is 6, my y is negative 3, 6 divided by negative 3 is negative 2. Cosine is my x value, so x over r, and I'm going to move this down. I know that x is 6. I know that r is 3 square roots of 5. If I simplify before I rationalize, 6 divided by 3 is 2 over the square root of 5. If I want to rationalize the denominator, again, you don't have to, but if you want to, multiply top and bottom by the square root of 5. You get 2 square roots of 5 over 5 for your cosine. Secant of theta, it does not start with a c, so that means its reciprocal needs to start with a c. I only have sine and cosine left, so it must be cosine. Reciprocal of x over r is r over x, which gives me 3 square roots of 5 over x, which is 6. Simplify your whole numbers. 3 divided by 6 is 1/2, so that becomes 1 square root of 5 over 2. Or if you want, you can just leave that as a square root of 5 over 2. Get rid of that 1. And cosecant, the only reciprocal left is sine. Notice that it starts with a c and sine does not. So it's the reciprocal of y over r, which is r over y. My r is 3 square roots of 5. My y is negative 3. Simplify, 3 divided by negative 3 is 1 square root of 5 over negative 1, or more simply, negative square root of 5. Now I know that some of you had questions on if you have a square root in the denominator with sine and cosine, do you multiply simply by the square root of 5, or do you multiply by 3 square roots of 5? You want to get rid of the square root, not the whole denominator. So we're only going to multiply by the square root of 5. So if you didn't simplify your fraction before you rationalize your denominator, you're going to ignore that 3. It's still 3 times whatever this is. And then you'll simplify it out, and you should still get negative square root of 5 over 5. So that's how you would solve problems 3 and 4.